Hello students, welcome back to my channel again. Today we are going to learn class 10's pair of linear equations in two variables. Methods for solving pair of linear equations in two variables. This topic we are going to learn today. Now there are actually 5 methods for solving. So the 5 methods are like this: graphical method, substitution method, and the third one is comparison, but comparison sometimes can be told as substitution also. So these two methods, then elimination method, and the final one is cross multiplication method. Now graphical method already we have completed in previous sessions. We will be doing today substitution method. Now one thing before we go to substitution method, I just want to say that these 4 or these 3, you can say, these 3 are algebraic method for solving pair of linear equations in two variables. Now substitution method. So let us consider these two equations, 2x plus 3y equals to 9 and 4x plus 8y equals to 6. Now this can be written in simplest form like 2x plus 4y equals to 3. How? Because we are dividing the whole by 2. Then we are getting this. Okay. So first equation, second equation I have named like this. Now this step 1, step 2, step 3. There are 3 steps for substitution method. Now steps, this statements part, don't write over there while you are solving two equations. You just do the calculation part. Now what you have to do? You have to find x in terms of y or y in terms of x from any one of the equations. That means you can choose either 1 or 2, whatever you like. And then after choosing it, suppose I am choosing number 1. And then you have to choose either x or y. I am choosing x. So we will find out x's value in terms of y like this. Okay. I had chosen 1 and then this like this. So 2x equals to 9 minus 3y. That means x equals to 9 minus 3y by 2. Now substitution method tells that you have to substitute this value in place of x in other equation. First time we have chosen 1, so we have to substitute the value in 2. If you are choosing 2, then you have to substitute the value in 1. Okay. So substituting the value of x there, we are getting like this: 2 into 9 minus 3y by 2 plus 4y equals to 3. So we are getting ultimately y equals to minus 3. Okay. So you have got substituting value, that is this one. Okay. And you have got y equals to 3. This is one variable's value. Now again substitution. Step number 3, that substituting this value, that means this one. In equation 3 means I'm just giving this one as 3. So you can put this one y equals to minus 3 in either 1 or 2, but this would be the easiest. So substituting the value, x equals to 9 minus 3 into minus 3 divided by 2. That means we are getting 9 plus 9 divided by 2, that means 18 by 2, that means 9 ultimately. So how we will be writing after this? That means x equals to 9 and y equals to minus 3, and this will be the answer. So you have to write the answer like this: x and y's value together, and then you write the answer. Okay. I hope you all have got the clear idea of this substitution method. Now, once you have got these answers, you need to perform the verification process. Now, how will you verify it? You just put x and y's value in left hand side of any one of the equation. Left hand side. If then left hand side and right hand side coming equal, so you can say that it is verified. So I will be choosing number 1. Left hand side equals to 2 into 9 plus 3 into minus 3. It's equals to 18 minus 9. Ultimately 9, and that is coming equal to right hand side. That means it is verified. Okay. Now there are some remarks, or you can say some of the important notes. So just look at this very minutely. If we get x and y's values very easily, that means like this that we have just done, then the system has unique solution, because you just got the solution as 9, minus 3. So it has unique solution, okay up to it. But suppose in the following case, that means this one, I have taken 2x plus 3y equals to 9, 4x plus 6y equals to 18. This is number 1 equation, number 2 equation. Now we will be doing the same substitution method. From number 1 I have taken x's value like this, then substituting x in 2, and we are getting ultimately 18 equals to 18. So after this you can tell that 0 equals to 0 or 1 equals to 1. That means I just want to say, suppose you are performing this substitution method and ultimately you are getting all the variable cancelled and you are getting some equal numbers in the left hand side and right hand side of equal sign. Okay, then what will be your conclusion? So I have written over here also that if you end up with this kind of situation of equality, you will conclude that the system has infinitely many solutions. Okay, infinitely many solutions. I am just highlighting these lines so that you can understand its importance. So if you are getting like equal type of things like this, then you will be concluding with the line, the system has infinitely many solutions. Coming to the next one. Now let's take, this is another case and this is another different case. So x plus 2y minus 4 equals to 0, 2x plus 4y minus 12 equals to 0. Now number 1, from number 1 we are just finding x's value as 4 minus 2y, substituting the value, same process, substitution process, and we are ending up with all our variables cancelled and we are getting minus 4 equals to 0. Minus 4 equals to 0 is obviously an absurd equation, absurd statement. So minus 4 equals to 0 can't be written. That means it is invalid statement. So what you will conclude? You will conclude as the system has no solution. As we are getting not a valid statement, so the answer will be the system has no solution. Okay. Now coming to exercise 3.3. You can check that I have written something before I start exercise 3.3's questions. Question number 1, Roman 1, 2, 3, 4 and 6 will be your straight away homework. And question number 3, that word problems, no need to do now. We will be doing all word problems in different sessions. Okay. I will be doing question number 1, Roman 5. Look at the question. Question is given like this. You have to solve for x and y. So root 2x plus root 3y equals to 0, root 3x minus root 8y equals to 0. Same process. I have found x's value from number 1 equation, substituting x's value, and then we are getting like this. The process you just look once, we are getting y equals to 0 finally. Now we are substituting this y equals to 0 in x equals to minus root 3 by root 2y. That means here. And we are getting x also equals to 0. So how I will write the answer? We all will write the answer like x equals to 0 and y equals to 0 together, and then answer. I hope you all have understood this process. It's very simple. Substitution method is very simple. There is no such difficulty in it. Coming to question number 1, 4 is your homework, but still I am just giving you some hint. Look, this is the equations given. So we can write the equations like this, breaking it into fractional form. Then we are getting like this, and then we can cancel 10, 10, 10 throughout. So we are getting finally 2x plus 3y equals to 13, and here 4x plus 5y equals to 23, which are very easy and quite similar that we have done already for substitution method. Then rest of the part you have to do. Okay. Now question number 2. Question number 2's equations are given like 2x plus 3y equals to 11, 2x minus 4y equals to minus 24. The solving part is your homework. Solving part I am not doing. So after solving you will be getting x's value as minus 2, y's value as 5. Now the question tells that y equals to mx plus 3 is valid for these two numbers. So we are putting x and y's value over there to find out m's value, and look at the calculation once, and finally we are getting m equals to minus 1. So the value of m equals to minus 1, and this is the answer. So I hope you all have understood the method substitution, which is very easy and important too, because this is the first algebraic method for solving pair of linear equations in two variables. So we have completed till today graphical method and substitution method. I will be discussing comparison method and elimination method in the next video. Till then, bye bye, and thank you everybody.